All right, you guys are about to do the Epsom Salt Lab. And what you're going to do is you're going to figure out if your electric oven is strong enough to produce 450 kilograms of anhydrous magnesium sulfate per hour. Now, the mine that we're using can only dig up magnesium sulfate heptahydrate. So what you got to do is figure out how much energy is required to produce this product from this reactant. Now, all you guys have as tools to use for this is the ability to dissolve each of these compounds in water and observe the temperature change. So you can dissolve magnesium sulfate heptahydrate in water, and when it dissolves, it's going to produce the magnesium sulfate and sulfate ions as well as the water, and this one's going to produce just the ions. You can calculate the energy change associated with each of these processes and use that, as well as Hess's law, to calculate the heat of the reaction. So in order to calculate the heat associated per mole of dissolving these substances in water, we're going to use our good old Q equals Cm delta T, where Q is the heat transferred, C is the specific heat. In this case, the energy is being transferred to the water. You're going to multiply that by the mass and then the change in temperature. Okay? So you're going to do that, and this is what some sample data might look like. And if you didn't get to do this lab in person, you're going to do it for homework online. This is your data you're going to use. So to calculate the energy you are producing, simply multiply the specific heat of water, which is 4.184 joules per gram degree Celsius, times the mass of water that we use, times the water's change in temperature. So that's going to be the energy either released or absorbed by your dissolving process. Then you have to divide that by your moles of solute. Now, given these masses, you can figure out how many moles of each of those components you used in order to get this energy. So calculating delta H is energy per mole. Knowing those energies, you can perform Hess's law again to figure out the delta H of the reaction.